Okay, kids, we're back still in section 12.1. And yesterday, in our little lesson there, went over some stuff that I think you're quite familiar with. And we're going to move on now to how exactly does an object become electrically charged? So the charge of objects is what we talk about today. So what does it actually mean? Well, let me tell you. An object is said to be charged if it has lost or gained electrons. As we saw in the video, electrons are particles that are on the outside of the nucleus. You learned this a while ago anyways. They're the ones that are easily moving. They carry a charge. But protons are stuck in a nucleus. They're not moving anywhere. So all of our discussion is always going to be about losing or gaining electrons, losing or gaining electrons. Sound familiar? It's like chemistry. Chemistry is all about electrons, and electrostatics and electricity in general is all about electrons. Why do you think it's called electricity? Because it's about electrons. So start with an object, we'll call it a neutral object. And in a neutral object, the number of protons is equal to the number of electrons. A lot of matter around us is all neutral. What can happen? Well, there can be a loss of electrons, so the number of protons is greater than the number of electrons. Then that object would now become a positively charged object. Next, this object can gain electrons. So now the number of protons is less than a number of electrons. It is known as a negatively charged object. A charged object that returns to this equality, number of protons equals number of electrons, becomes neutral again. And when that happens, that particle is said to have been discharged. Discharged. It's gone back to being neutral. All right. Now, how can that happen? Well, that can happen by a process called grounding. You connect a charged object to the earth for discharge. Now, you usually connect it through a wire or through a conductor, but here's the object, and through an electrical conductor, it is connected to the ground, to the earth. And the earth will give a positively charged object, it will give it electrons. The earth will take away electrons from a negatively charged object. The earth is so big it has the capacity to do both. And right here, there's a symbol. Right here, it's a line, then it goes down, then 1, 2, 3, sometimes 4 little horizontal lines getting smaller and smaller. That's a symbol for a ground, when an object has been ground to discharge an object electrically. Well, how can an object go about getting charged? Methods of charging. How can an object become charged? Well, there's three ways it can do that. By friction, by conduction, which is also known as contact, and by induction. Those are the three ways that an object can be charged. Now, this is what I want you to do right now. I want you to stop this video, pause it, okay, pause this video, stop it, and I want you to watch segment 2 and segment 3, the link of a video. The link is on the web page. All right, right here. These videos right here. Okay. Yesterday I asked you to watch the first segment. Today I want you to watch segment 2 and segment 3 of this video. And then we can come back to the note I've given about it. But the note will make much more sense if you watch the video first. Okay, so do that and we'll be back. Bye-bye. All right, I hope you watched segment 2 and segment 3 of the video because that'll make this much easier for you to understand. So the first method, charging by friction. There are two materials of different types. They have to be different, and they're rubbed together. That's where the friction comes into play. One material has a stronger attraction for electrons. The other gains electrons and becomes negatively charged. Okay, so one material has a stronger attraction for electrons than the other. It gains electrons and becomes negatively charged. It literally pulls electrons. The other material has a weaker attraction for electrons than the other one, right? And it loses those electrons to that one and it becomes positively charged. Well, how do we know which material has a stronger attraction for electron, which material has a weaker attraction for electrons? Well, on page 427 of our textbook, page 427 of our textbook, we can look that up and it rates materials. So why don't we investigate that a little bit? Now, I know you all know this, but in the resources that's posted every day, there's a link there to the 3U textbook. So that's what you're going to need. Most of you probably have already downloaded this link, so it's permanently on your computer, or maybe you brought the textbook home, what have you, but the link is there. So here we are on page 427 in the textbook, table 1, the electrostatic series. So materials up here, acetate, glass, wool, fur, human hair, weak hold on electrons. Things down here like rubber, plastic, things like that, stronger attraction for electrons. So simply put, if you were to rub rubber on fur, the fur would has a weaker hold on electrons, and it would give its electrons to the rubber, which has a stronger attraction for electrons. Now, this is not a complete list. This is just a representation of a few very common materials, but that's where you would look. So as I said, we just looked at page 427, and you simply rub two materials together, and you saw it in the video. Hopefully the video helped you understand that. And we have a transfer of electrons. Remember, protons never move. Next, charging by conduction, also known as contact. Well, charging by conduction, contact is just what it says. A charged object is placed into contact with a neutral object. The charged object shares, and that is the key word, shares its charge with the neutral object. So if you have a neutral object and a positively charged object, the electrons move from the neutral object into the positively charged object, and then if you were to separate them, they would both be positively charged. If you have a neutral object and it's in contact with a negatively charged object, the electrons move from the negatively charged object into the neutral object, and if you were to separate them, they would both be negatively charged. Just all about sharing electrons. All right, the third and final one is called charging by induction. And the word induction is here because induction means that the charged particle, the charged object, I should say, and the neutral object never really touch. So it's charging an object by bringing a charged object, here's the key word, by bringing a charged object close, close to a neutral object. And you need some help to get this done, so you use a ground. So let's say we have, as we saw in the video, an electroscope. Remember, if you're really going to try to understand this, you should have watched segment 2 and 3 of the video first. So here's the electroscope that they had in there, and it was neutral. Same number of protons and electrons. Then what happens is right up here, we bring close to it, but not touching, a negatively charged object. And what happens is the negatively charged object, it repels electrons downward to the bottom of the electroscope, that object that you saw in the video. It hasn't lost or gained electrons. So this electroscope is still neutral, but the bottom end of it is negative, and the top end of it is positive. It's called an induced charge separation. So that's the second step. The third step is you connect the electroscope to a ground. There's a symbol for a ground. So now the electrons are repelled away. So the electrons leave the electroscope because they have this tendency to get as far away from a similarly charged object. Electrons are negatively charged. This rod is negatively charged. There's repulsion. They have a tendency to get as far away as they possibly can. And now a path has been given to them. So the electrons zoom, get away, go down into the ground. So as I wrote here, electrons are repelled to the ground. So now the electroscope has lost some electrons. It's lost some electrons once the electroscope has been connected. It is no longer neutral. It started neutral, but it's no longer neutral because, as I wrote here, electrons are repelled away. So then you remove the ground first, or it's got to be removing the ground first, and then the negatively charged rod. And what happens is that since this electroscope lost electrons, this electroscope now has a positive charge. So what's really interesting here is uh, charging by induction creates an object that has the opposite charge to the object that was causing the charging. Look, I used a negatively charged rod here. I brought it close, didn't touch it, but I brought it close. And the end result of using this negatively charged rod and the ground is that this object is positively charged. So it's opposite. Not like up here when we were doing charging by contact, right? When we're doing charging by contact, neutral object and a negative object, eventually they both become negatively charged. Neutral object and a positive object, they both become positively charged because up here it's all about sharing, not here. Here you get the opposite effect. So between this note and you had to watch segment 2 or 3, it's a very good video. Hopefully you'll have an understanding of charging, and I'll give you some questions to do about that, and have a great day. Bye-bye.